All right, let's talk about something that's totally changed the game in the world of big data: Delta Lake. For the longest time, we had this idea of a data lake, a place to dump all our data. The problem? It often turned into a data swamp, just a messy, unreliable mess. Well, Delta Lake is the tech that finally lets us tame that swamp. So let's get into it.
But before we get all technical, let me just ask you this. What if your data had an undo button? I mean a real one. What if you could rewind your entire data set to see exactly what it looked like last week or last month? And what if you had a perfect, unchangeable record of every single tweak ever made? Just hang on to that thought, because that's exactly the kind of world we're talking about with Delta Lake.
So why was this even necessary? Why did something like Delta Lake have to be invented? Well, to get that, we need to understand the huge problem that was plaguing the first generation of big data systems.
You see, the initial promise of big data was massive. We were told, just store everything in a giant, flexible data lake, and you'll get these incredible insights. But the reality? It was usually a total nightmare. We got a data swamp, just a chaotic mess of files, jobs that would fail halfway through and corrupt everything. There was just no way to guarantee consistency. I mean, trying to build reliable machine learning models on top of that is like trying to build a skyscraper on quicksand. It's just not going to work.
Okay, so before we can really see how Delta Lake fixes all this, we need to talk about the engine that it's built on top of. You really can't understand Delta Lake without first getting a handle on its foundation, which is the data processing beast known as Apache Spark.
So what is Spark? Super simple. It's an incredibly fast open-source engine that's designed to process gigantic data sets by splitting the work across a whole bunch of computers at once. And here's the fun part. The very same people who created Spark went on to start the company Databricks, and they created Delta Lake. So you can see it's all part of the same story.
To get how Spark works, think about it like this. Imagine you're back at university, and there are 3 computer labs, each with 30 computers inside. Now, what if you could magically link all 90 of those machines together so they acted like one giant supercomputer? That's basically a Spark cluster. It lets you chop up a huge task and have all those machines work on a little piece of it in parallel.
And the way the cluster coordinates everything is kind of like a 3-step dance. First, you tell the cluster manager what you want to do. The manager then spins up a driver program. Think of the driver as the conductor of an orchestra. It's not playing any instruments, but it's telling everyone else what to do and when. And then the driver hands out all the tasks to the worker nodes. Those are the actual computers doing the heavy lifting. Now, the great thing about platforms like Databricks is that they handle all of this complex orchestration for you behind the scenes.
Okay, so we've got this amazingly powerful Spark engine, but we still have that data swamp problem, right? This is where Delta Lake finally comes into the picture. It's built right on top of Spark to bring some much-needed law and order to that chaos.
So here's the single most important thing to know. Delta Lake is an open-source storage layer. It sits on top of the files you already have. It doesn't replace your storage, it just makes it way, way better. It gives your data lake the kind of reliability you'd normally only find in a traditional database, mostly through something called ACID transactions. All that means is that a data job either finishes 100% successfully or it's like it never happened at all. No more half-finished, corrupted data. And honestly, if you're interviewing for a data engineering job today, you absolutely have to know this stuff.
So how does it pull this off? Well, the secret sauce, the absolute core of Delta Lake, is something called the Delta Log. This is that unbreakable audit trail we imagined at the beginning. It's such a simple but brilliant idea. It's just an ordered log file that writes down every single transaction, every time you add, change, or delete data. This log becomes the one and only source of truth.
And that simple little log file, it unlocks a whole set of incredible features. I like to think of them as Delta Lake's superpowers. These are the things that directly attack all the problems we had with data swamps.
So what are these superpowers?
Well, you've got ACID transactions, which we just talked about. That's what guarantees reliability. Then you've got schema enforcement, which is like a bouncer at the door of your table, making sure no badly formatted data gets in. Then there's time travel, our undo button for data. And finally, there are all these cool built-in performance optimizations that just cleverly organize your data under the hood so your queries run so much faster. Altogether, these are what turn a swamp into a high-performance, super reliable lakehouse.
And here's that time travel feature in action. It's so cool. Every transaction that gets written to the Delta log creates a brand new, permanent version of your table. So version 0 might be when you first load the data. Then an update creates version 1. A delete operation creates version 2, and so on. And with a really simple command, you can literally ask Delta Lake, hey, Show me what the data looked like at version 1. It's the undo button for your entire data lake, brought to life.
So this all sounds great in theory, but what does it actually mean for people doing this work every day? Let's take a look at why understanding Delta Lake is pretty much non-negotiable for a career in data right now.
This quote from a guide on ML Ops, or machine learning operations, really nails it. If you're building machine learning models, you have to be able to reproduce your results. It's fundamental. And that means you need to version not just your code, but the exact data that your model was trained on. Because if that data changes, even a little bit, your model could behave completely differently. Delta Lake's time travel makes versioning your data incredibly easy.
And it affects the entire data team. Your data engineers can now build pipelines that are way more robust and reliable. Your data scientists can finally trust the data they're working with, and they can easily go back to an older version of a dataset if they need to. And the MLOps engineers, the ones deploying all this stuff, can build systems knowing that the entire data foundation is solid and reproducible.
What this all boils down to is that Delta Lake lets us treat our data with the same level of discipline that we've always treated our code. In software development, we have CI/CD pipelines to automatically build and test our code. Well, Delta basically brings that same power to the data itself, letting us version, test, and deploy data changes safely, right alongside the code and the models that depend on it. So when you take all these pieces and put them together, when you combine the massive scale of a data lake with the reliability and performance of a data warehouse, you get a whole new type of data architecture. And it's quickly becoming the new industry standard.
And that new standard is the lakehouse. It's not just a data lake, and it's not a data warehouse. It's a new approach that gives you the best of both worlds. You get the cheap, flexible storage of a data lake, but with all the powerful management features like ACID transactions and time travel that you used to only get from a really expensive data warehouse. Delta Lake is the technology that truly makes the lakehouse architecture possible.
And that really brings us to the final idea here. For so long, the biggest challenge with big data wasn't about the scale, it was about trust. We could store petabytes of data, but we couldn't always rely on it. Delta Lake changes that equation completely. So the question we have to ask ourselves now isn't, can we store all this data? It's, okay, now that we can finally trust our data, what amazing problems are we going to solve with it?